Recordings on?
Yeah, recording's on.
All right. Welcome, everybody, from many different countries and Norway. So just to remind you, the textbook we are using is the Systems Enterprise Architecture text, a QR for getting the text download. And at the bottom of every page is also the a link, tinyurl.com, Syst Arc book. So, and you're welcome to share that book with anybody. We're recording every session. Here's one link to one session. Right now, the sessions are listed on the meetup forum. We're going to try and make them more centralized, but you can catch up or share the recordings with anybody else, and this session is being recorded. So we have 1 hour of lecture and 1 hour with 1/2 hour with questions. So please prepare your questions. You can put them in the chat or ask. It's very nice if you ask them orally at the end. We can have very nice discussions. Good, we have 20 participants at the moment. That's fine. So I'm going to skip, as I have a very long session today. Here, by the way, is the outline of everything, and we're here, Chapter 4, Architecture Decomposition, the Secret of Project Success. Okay, and on Thursday, we're going to look at prioritization, but this is a very big topic. I doubt very much if I'll get through it all, but I'll do my best. Let's see. So go to 4, 6, 5, and there we go. Number 4. Okay. So decomposition. Let's see. Right. So decomposition is just simply dividing up the possible delivery, the step-by-step or sprint-like delivery. An analogy is dividing an epic into user stories, but we're going much further than that, but that is one possibility. So there's a formal definition of decomposition. There's also a nice quotation from my favorite decomposer, René Descartes, who believed that solving very complex problems began with decomposition. And then understanding the decomposed parts, we can think about that as delivering one of them and getting feedback, in other words, agile. And then piecing it all together, we can think of that as being incremental, okay? So I've borrowed from my Eduneering book. You'll find the link to that. It was written 2020 summer at the back in the references. So I borrowed some decomposition principles. So this is decomposition for education and knowledge, but the principles are quite general. So these pages, I'm thinking of spending a little time on each one of these ideas. So the first principle is that decomposition of a system specification can be done at many levels and for many different purposes. So we'll look at those levels and we'll look at those purposes. Decomposition is a basic tactic to enable us to describe, by the decomposed components, a complex system. And one of the reasons we like to decompose big, complex ideas is that we can focus on critical things early. So this, in fact, is a prioritization method, our topic on Thursday. And we want to focus on critical things early to make sure we deliver maximum value early and to make sure that any risks or problems are sorted out early. Another reason for the decomposition is to see the cause and effect better. If you do 10 things at once, something bad happens, you don't know which of the 10 or any set of them that has caused the problem. But if you divide something into 10 pieces and do one at a time, and something bad happens, the feedback from your incremental delivery, then you're pretty good idea that that probably is the cause of the effect. And then you can change and modify what you did or eliminate it so it doesn't have a bad effect. Another purpose of decomposition is to allow incremental progress towards longer-term, larger changes. So for example, we may have a fantastic objective for better and better security in 2 years' time, but maybe every month we might make some incremental progress towards the security, and rather than waiting for 2 years and delivering it all at once. Another good reason for decomposition is to limit the damage from bad decisions, so that when something bad happens, a negative increased costs, time, or reduced qualities or bad side effects, that they will be small defined as maybe 1 week of effort, or maybe 2% of the total budget of time or money. That's my definition of small in practice here. And then reversible losses. In other words, we can yank it out and we're back where we started from, and try again, either with a better version or with some entirely different things. This is absolutely fundamental to my form of Agile, which is known as EVO, evolutionary delivery. The definition of doing exactly this, I wrote in my 1976 book, Software Metrics, page 217. So that's an early definition of Agile as it should be. Okay. One central idea is to get to the detailed level, which is simple to act on. In other words, it can be done quickly with few people and few resources, and we can understand that little thing in itself, and we can understand that it is perhaps the cause or not the cause of something bad that happened. There are many different methods of decomposition. I've here written up over 20. I believe that people need to learn the methods, and these are not always intuitive for everybody. They started out being intuitive for me, and then I thought, why not write them down so that other people get them, and we can teach the method of decomposition systematically. So some of these methods are more useful in certain circumstances than others. But to simplify the rules, first, when we decompose, we need, let's say we decompose an architecture for security into 10 different sub-architectures for security. Then rule number 1, and this is critical for Agile, is that each one of the 10 can be implemented independently of the others. There are no dependencies, no prerequisites. I can choose any one of them because I want to, or because it has higher value to cost, lower risk, or any other reason. So this notion of independence is not obvious when I first ask students decompose. Then they normally don't think too much about the independence. They just think of some kind of bill of materials decomposition. And so now the second condition when I'm teaching my form of Agile is that these independent decompositions, call them sub-architectures, when implemented, when incremented into the current system, they will give a measurable result. They will give value, okay? There's not much point in implementing something that doesn't give value, even though many people practice Agile without that consideration. They're just happy to get maybe some user stories implemented, and hope that they have value. But no, in other words, if you primarily believe that the reason for this architecture is security, and the reason for each sub-architecture is also security, then when you implement each of the 10 will give a measurable result. And in the direction, and all 10 of them will maybe go in the direction of the final long-term objective for security. Lots of different things can be decomposed. I've focused for the moment on what I call strategies or architectures, but in fact we can decompose objectives and time and budgets and by stakeholder and lots of functionality and constraints and lots of other things. So there are very many potential objects for decomposition. Here is our EVO cycle. It's a kissing cousin of the plan, do, study, act cycle of Deming. And here we have the decomposition area. So we've identified some stakeholders. We talked about this to begin with. We've identified their critical values, like enhanced security. We've identified some solutions, like major architecture for security. But maybe if that solution would demand a year or a billion kroner or something like that to implement, then it's too big to just do all at once. So we will decompose it into smaller parts, like the billion into millions, or the year into months, or the year into weeks, or something like that. So decomposition is very, very fundamental to agile delivery of value. And then the decompose steps can be acquired, that's what developed means. And then delivered means integrated into the current system, which you're trying to gradually move towards all your objectives. And then we can measure what happened. Did we get the security we were expecting? Was the 1 week cycle just 1 week, or did it take you 4 weeks? And we learn primarily about negative things, but we can also learn about positive things and make the best use of them. And we can continue this cycle. Sometimes you can go directly from learn to some decomposed solutions, skipping over this if you've already essentially done it. Here's a simple example of real value decompositions, where here is a set of solutions for clean air in London. And one of them, advanced congestion charges. I asked, this is a student exercise like we do at OSWA workshops. And I asked them to decompose it into sub architectures. Here they are, D1 to D8. And all of these, I've asked them to make sure they could do any one of these in any sequence, and that any one of these would somehow be a congestion charge strategy, which hopefully would impact the congestion itself. The little light bulb is a symbol, of course, for bright idea, solution, architecture, or anything like that. If anybody wants to go far deeper, about 651 pages of deep into decomposition, take a note of this link to my value planning book chapter on decomposition. Okay, so that's the greatest depth I've ever written anything about decomposition. Okay, maybe one day a whole book on decomposition. Once I made a remark on a course in London, I could hold a one-day course on decomposition, and I got challenged to do that, and I did it. So I can hold a one-day course on it. This is the 1 hour version of the one-day course. Here are some decomposition tactics. So, for example, if you have 10 critical value objectives, we could say, let's tackle security, and that would be a decomposition. And then after that, let's tackle user friendliness. So we can decompose by value requirements. We can decompose by functionality. For example, let's do all the functionality to read things, and then second step, let's do all the functionality to write or change things. Here is decomposition of architecture, which I just showed you, where we've got all the strategies or architecture here, the top 10 strategies, and then each team responsible for one of these takes one of these and decomposes it further order of magnitude and gets these. Now we have things we can maybe do in a week, even though this would have taken a year to do or something like that. Okay. We can decompose by delivery time. That is, just decide to do things every month, no matter what, and then figure out what to do. And skip that one. But we can also decompose by stakeholder, for example, serving all the nurses in the health system and all the surgeons in the health system, and then all the hospital administrators, and then maybe the patients, and maybe the lung cancer patients. Okay, so in other words, there are lots of areas to look and find ways of decomposing. Okay, so here really is some detail on that, and I think I don't want to spend the time on this particular detail, except to say this is more text or more detail explaining these ideas here. Okay, so moving right along. Why do we decompose? I've given some basic reasons, like we want to get results early. You'll find management support for that in principle, I guess. And we need to see the cause and effect. But here is a better list of why we want to decompose. First, in my EVO Agile method, which by the way is free, and you don't have to get certified in it, you just have to learn it. We want a stream of value, and these values are the stakeholder values. Many of them are qualities, which is why I give the example of security and user friendliness, but they can be anything the stakeholders value. And what we want is, in simple terms, every week, generally speaking, this can be adjusted, but every week we want to see results. We want to see measurable results in the direction of our longer term objectives. Another reason for decomposition is to simplify. We can have a big package of say, security tactics that'll take a year to implement, and there may be something in there that is unintelligible and sort of hidden and is going to destroy everything. So by decomposition, we can more easily understand what we're doing. We don't have 10 other things. We just have this one thing to look at, and we plug it in, and we just don't have to worry about the other things yet. Okay. Now here's this reason I believe all managers are for, even though I found that IT people don't seem to care one way or the other. But if you ask a manager, would you like some business results next week instead of in 8 years? I'm referring to the Norwegian Axon medical system. The managers, the ministers would probably say, we'd like this option of measurable improvements on our values every week would be very nice and comforting. Okay. So maybe before the election, or before the financial results, or before the manager gets fired. Decomposition allows us to get extremely early results. Okay. Another reason for the decomposition is that we don't have to do all the detail of the architecture up front. For example, if we think about the Axon system in Norway, 8 years were done on a preliminary study, and presumably that study provides the architecture of the system. Wouldn't it be nice if each month of those 8 years, something was delivered to the health system of Norway? Instead of spending, the idea of spending 8 years before you start a large project in a small country like Norway is ridiculous, unnecessary, but in fact, that's what we're doing. In the old days, we called it Big Bang Waterfall, and I thought that had died, but apparently not in Norway, and we just got a Swedish example of the IT system for teaching, which was a total catastrophe. same problem. So, and I suspect many organizations are still, they say we're doing agile, and what they mean is we're writing the code using user stories and sprints, but they really aren't delivering the results early, frequently, and incrementally. And that's why we have these gigantic, embarrassing public failures. So if the Prime Minister of Norway or Sweden is listening to me, this solution is very simple. Teach people to decompose and insist they do it so that real results to the health services can be delivered early, frequently, continuously, and incrementally. That's agile as it should be. When will we ever learn? Okay. Now, delivering in small, limited packages, we can get several kinds of feedback. And number one, did we get the value we wanted? Did the security increase as much as we hoped? We can also look at side effects, that is other values. What happened to user friendliness when we did this? And was it negative or positive? We can look at costs, all kinds, time, people, and money. And then we can look at human reactions. You know, did people adopt the Smittestop system or not when we gave them a chance? And if we get early warnings, especially about negative things, that gives us a fair chance to adjust our architecture, or maybe to adjust false expectations that unfortunately these COVID's going to last longer than anybody hopes for. Is the latest false expectation we're confronted with today, if not before. Vil, oh, okay. Little typo there. Now, one other opportunity is that we can do things in parallel, like the security team could be in parallel developing the enhancements to the system together with the friendly team. And they, for example, at Confirm It in Norway, we had 4 parallel teams doing development at all times. And that was just 4 times 4 people, 16 people total. And that seems to work quite well and obviously speeds things up. So there, I'm not saying here you have to have one single value stream. You can have multiple streams in this way. Here's a little example from dividing things up in, we did, so dividing things up by country or region is a simple example. Now here from, let's see, cooperation with companies, yeah. This is from the Polish group of 60 people in 20 parallel teams of 3 people each. It's a training course like we do in London and in Oslo. And so basically each one team had one of these. And then I asked them to decompose by about 10. And here is, in fact, the result of what they did, just so you see an example. So here's spread brand awareness, and here is the decomposition of that. And hopefully they followed my instructions. I check up to a point, can each one be done independently, and will each one deliver some value? And here's value planning, consulting, and the decomposition of that. So this is just to give you a realistic example. Again, whenever we do this, we discover that everybody can do it, can agree that these are independent, can agree these should give measurable value. And they do this in half a day, basically, or something like that. So it's not difficult to learn to do it properly. And we never encountered a situation where people said it cannot be decomposed. I find when people have a block and they say it cannot be decomposed, it's usually they've misunderstood something, they don't have enough methods to do it, they need some coaching perhaps from some of you Agile coaches, but there doesn't seem to ever be any real problems, okay? So here is just another example enlarged. Okay, and that's enough of that. Here we're using our tool Valplan, which basically has produced these diagrams automatically from digital information. So here is expanding qualification activities. In other words, same as that major architectural idea. And then it consists of, and each one of these is a separately, digitally separate solution idea, okay? And then using this digital information, we can draw diagrams and keep diagrams like this up to date. Okay. Now, here again, using Valplan, here we have the sub-architectures. Digitally, we put them onto a table, and we have rated their impact on different objectives. These all seem to be the same objective, but in fact, they're not. There are different skill levels and different employee types and different, so there are different variations of the larger. We've actually decomposed the adequate qualifications objective. Here it is in detail, okay? Now, if you want to understand this kind of thing in detail, you'll have to go to the end of the book about chapter 11, where I go into detail about these things like scale of measure and status and things like that. But just doesn't, for our purposes here, just assume there is a set of different objectives. We have decomposed our larger architecture into D1, D2, D3, D4, etc. And then we have, as we've talked about earlier, rated or estimated how good D3 is for this objective, and it gets 87% out of 100. 100% would be gets us to this objective on time. And D4 gets 23% if we were to do it alone and first. This is if we were to do it alone and first. And D2 gets 38% and D1 gets 51%. Now we can see from this that if my objective is to reach this objective very early, then the D3 is going to be the correct decomposed sub-architecture for getting there. These others are arguably weaker. Now, none of that, we've also estimated on our impact estimation table how much impact we got on the second goal for this, and that was 93%. Wow, wow, wow. And on the third goal, we get 60%, damn good, and not too much on the other two goals. But if we add up these numbers, which are a set of how much we would get on all the goals there, we get this magic number, 246, 228, 144, 104. What it's doing is saying that this particular sub-architecture, which we've decomposed D3, is 2.5 times more powerful than D1. Okay, therefore it would be smart to, and we actually have asked, there's a little thing here called sort the sub-architectures in sequence based on their value. So it's done that. So here's really the head of the queue. Here I've really done my product owner work of deciding which of these 4 I should try to implement earliest, simply because it seems to give the most. What if a manager pipes in and said, but I want you to do this D4, invite experience? Well, I'd say, okay, doesn't make a whole lot of difference. Just to please you, we'll do it. Okay, so that's not gonna, these numbers are not exact, but they should be order of magnitude correct. And this should give a lot more than that. It doesn't seem like a good idea to choose a loser, but that you've estimated yourself as a loser and say, I hope I get lucky here, and this probably wouldn't work anyway. That's just not being logical. Okay. Now, if you want more detail on how we estimate these things, again, going to the end of the book, chapter 11 or 12 on impact estimation table, goes into detail about how we do these estimates. We haven't planned to hold courses on the chapters at the end, but I'm going to talk about it, and we'll see if there's a need for it or desire for it, going through those chapters 10, 11, and 12 at the end, which are details about values and details about the table. Okay, now here we hit another little button saying show me the bar chart, and show me the bar chart for total value and total cost. So this bar here is exactly the same as this 248 over here, and this bar here for D4 is exactly the same as this 231 here. These are actually sorted not by value alone, but they're actually sorted by I think I have to double check it, but they're probably sorted by value to cost ratio, and maybe with regard to worst case, where here's the worst case, worst case, worst case, worst case in a range of possible things. So we're looking at risks, we're looking at costs, and we still end up with D3 as the winner because its worst case is quite good and its cost is quite low and it beats the other ones. So again, this is automated product owner. This is a rational, logical decision based on the data we develop here, which is the value. And then below this, we evaluate costs. And we also have another place outside of this picture where we evaluate the plus minus uncertainty and the credibility of the evidence we used to estimate. So again, more detail on that is out of scope here. We're looking primarily at decomposition. But by decomposing, we can pick a certain winner. That is, even if we're a bit disappointed about the value, we're still going to get a lot. And even if we're disappointed about the cost and it's a little bit more, the value to cost ratio is still going to be pretty darn good. Picking any of these other guys here, which I think have no value because nobody has estimated the value yet. But so let's start here where we have estimated. Picking a loser as the first thing you do isn't such a smart idea. And you need a policy saying we're going to evaluate and we're going to choose the winners according to our estimate. And then we'll see how good it did compared to our estimates, the feedback, and we will learn. And if we consistently, like at Confirm It, they consistently got the kind of results they thought they would get, so they knew what they were doing. If we consistently get very different results, it means we don't know how to estimate, we don't know what we're doing, and we need to be very, very careful. Okay. Let's see. Here we have a concept called backroom development and design, and I'll go through it quite quickly, but there are some references here and there to it. What we found is that, take an example. Let's say you want to deliver every week, but something you want to deliver in the first week has a delivery cycle of 10 weeks, and there's nothing to do about that. Well, you can't deliver it in the first week or second week or third week. You're going to have to wait 10 weeks to deliver it. And in a sense, it cannot be decomposed so that you can deliver it in the first, second, third week. So what we're going to do, we're going to do exactly what the chef in the kitchen does with certain things. For example, things that take a long time to cook or acquire or cool off or something like that. They do other things first, and then when the 10 weeks have expired, we can deliver it. It may just be a small step, but we can deliver it as step number 10. So in other words, what we cannot do is decompose absolutely everything. When there's a fixed delivery time of 10 weeks, we can't do much about that. What we can do is do other things every week. So we have a stream of change and a stream of value, and then do that thing on the 10th week when it is delivered. Okay, so that's what backroom is. So front room is like in the restaurant, delivering the hors d'oeuvre and the main dish and the dessert and the coffee in a value sequence as needed by the customers. What the kitchen does is something entirely different in sequencing, but the main idea is to keep the value stream running in the restaurant, even though we have to do special things with special situations in the back room. So if you like, we've adopted the kitchen and restaurant analogy as a way of solving what seem to be insolvable problems. Here's the front room delivery. See, in the front room, even though this thing at stage 6 took 6 weeks before it was ready, it still can be delivered as a small increment in increment number 6. And increment number 1 to 5 just had to do something else that didn't have to wait 6 weeks. From the point of view of the person in the restaurant, they're getting a stream of what they want to eat and drink and have coffee, and they couldn't care less what's happening in the back room. That's the business of the kitchen. So to be even clearer, what I'm saying is we can't always divide everything into, for example, weekly increments in themselves. We may have to wait for development of something or delivery of something, but we can, in all the different parts of the system that have to be done, probably find a value stream of something to do week by week by week, so that things are happening, improvements are happening, we're getting feedback, we're learning, and people are feeling good about everything getting better. Okay, so in the competitive engineering book, which you have a free link to and a free copy of in the references in the back, in the chapter on Evo delivery, chapter 10, I think, you'll find more information about backroom and front room if you want to go into depth on that theory, which we found eminently practical. Okay, so from the point of view of the users in the restaurant, there is a stream of value being delivered, and in the direction of their long-term goal. And of course, when we may have had to pay upfront for that thing to be delivered in 10 weeks' time. So it was constant consumption of our resources, such as money and time, are happening. But our main objective is to deliver the critical values to the stakeholders in a stream without them being very aware of the architectural idea of this cannot be subdivided, therefore we need to wait 10 weeks before it becomes a possible increment. Here is another view of the whole thing. Here's our Evo cycle again. And here is conventional Scrum. And what we're doing is getting control of values and design and architecture. So that's this value management here and value management there. And I don't think there's enough value management. This is something my friend Jeff Sutherland, who co-invented Scrum, agrees on in public, in writing, that we need to add things like better value management. He specifically cited the work done by Kai Gilb at Bring as a very advanced example of doing exactly this, more advanced than anything he'd seen in Scrum in the world. But here's conventional Scrum, which is very focused on churning out tasks and work. Nothing wrong with that, but if you haven't even stated your values quantitatively and you aren't getting feedback whether you're delivering them, you're not likely to deliver high value in every project consistently and early. So all of my methods are devoted to the idea that whatever the work here, because we can do this on systems which are not delivering code, not using any aspect of Scrum, but there's just some tasks and work there. And it's the idea of managing the value at different levels and getting feedback on the work, the consequences of the work being done. So Now here's a very interesting guy, Robert Quinnen. I cooperated with him and Harden Mills at IBM Federal Systems Division many years ago, where they developed the clean room method, and you'll find a link to that. Strangely enough, not on IBM's sites, but on University of Tennessee sites. But this is a very, very advanced agile method and a very, very advanced architecture method. And Quinnen is the architect, and Quinnen describes what I today called dynamic design to cost, where at each of, for example, 50 increments of, for example, space shuttle ground software, to be very specific what they were doing, he takes a look at the results of the increment and said, if good result, go ahead. Continue with next increment. But if bad result, like we're not getting the security we want, he as the architect intervenes and improves the architecture, maybe ripping out the bad architecture, maybe modifying it and giving it a try, probably on the next increment. So that's so design to cost is where the architect is responsible both for the costs. So if they thought they had a monthly increment, but it took 3 months, we need to design something that will only take 1 month every time we do it. And that's called design to cost. Look it up, well-known engineering technique. But dynamic design to cost is agile. It means on every one of the sprints or steps, the architect intervenes, gets information about what's real, about the costs and the values, and conjures up better architecture in the middle. So that's a fascinatingly advanced agile architecture idea. The result of this was published, and that was all of their state-of-the-art military and space projects were delivered for years on end, without exception, on time, under budget. Now, if you don't have a method today that delivers all of your projects for years on end, on time, under budget, no matter what the complexity or the high level of quality, then you need this method. It is identical to my EVO method, and here it's called the IBM Clean Room method. So, and there's a written description of how it works, and there's the documentation, okay? IBM, interestingly enough, never sold that method. They just used it internally, published it in IBM Systems Journal, number 4, 1990, and left it at that. I discovered when working with IBM that most IBM employees didn't even know about it. It was buried because IBM wasn't in the business of selling their good methods to other people at the time. Okay, so let's see. We're doing fine on time. Here is the quotation I cited from my software metrics book, and it's 1976, note the date, but remember I began at IBM 1958, and I began delivering my first agile system 1960, 16 years earlier. So I have 16 years of practicing agile in 76, and I wrote down, a complex system will be most successful if it is implemented in small steps. Remember, this is the time of the Big Bang waterfall, and people thought this was a crazy idea, but I knew it worked because I did it. And if each step has a clear measure of successful achievement, got it? In other words, we have quantified the value, and we know what we're expecting of enhanced security. We're going to move from 90% probability of catching the hacker to 95%. That's our successful achievement for this increment, as well as a retreat possibility. This is like the architect saying, aha, you only got to 85%. We were expecting 90%. Therefore, let's yank out that bad architecture for security. Let's put in a better one that'll get us to 95%, and let's try it out maybe on the next increment, okay? So in other words, there's always a risk that we will be disappointed, but we can measure it in small increments if we have decomposed wisely, okay? And now, of course, this is 44 years ago I was giving this advice, and apparently I'm still giving the advice. And so question is, do you need another 44 years until you understand what I'm saying? I suspect the larger community does need another 44 years. I won't be around, but maybe some of you will point this out, that it's been around for a long time. This is the origin of Agile, and the guys who signed the manifesto credit a later book than this, this one here from 1988, Principles of Software Engineering Management, which goes very much deeper into Agile, and you can still buy a paper copy of it if you want to go into more depth. But I'm very proud to have clearly stated the essence of Agile in 1976. And you can only get a copy of this book by buying a used one on the internet, but you can do that. Okay. Let's see, what's that? Okay. Now here's another view of what's going on. If this be the functionality of the system, this oval here, and this arrow be one value, critical stakeholder value, the usability, just to give it a name, and this is another distinct value we want to enhance, the speed. Here's how bad we were to begin with, and here's the minimum we wish to achieve, the tolerable level. Again, read all about it in chapter 10 or 11 in the back of the book, what is tolerable, what is past, things like that. And then here's our goal. So below tolerable is the failure area, okay? And below gold is the not quite successful, but we'll live with it. At the goal or above is what we call the success level. So we formally and numerically define success and failure in each one of our critical values, okay? We do the same essentially with our resources. You know, there's something, well, we won't get into that there, but it's in the book. Okay? But we have budgets and how much we can exceed a budget and still get away with it and things like that. So what's happening is these different increments are being plugged in to, we start with the existing old system, no matter how bad it is. I mean, the existing NAV system, the existing one patient, one record system at the hospitals. And we start incrementing it towards its glorious future some years hence. And so each one of these represents the measurable increment for increment number 5. And increment number 5 also impacted the speed, but increment number 5 ate up this much money, and increment number 5 ate up this much working time. Okay, so we have, and in practice, you have at least the top 10 values and probably 2 to 5 different resources. And the idea is we're keeping track of these at all times. So this is what I call systems engineering. We're looking at, and one part of systems is all the values, not just one, and all the resources, not just none or one, which is very common. And system goes beyond, and system looks at the functions, and it looks at stakeholders, and it looks at everything essential for reaching success in a reliable and predictable way. Hot chocolate, good. Okay. Now, it turns out, surprising myself, but perhaps because I skipped things, that I've finished the lecturing. We have 10 more official minutes on lecture. And let's see, a little bit of a summary, and then we'll go into questions. So get your questions ready. But I'll maybe scan through the essential ideas of architecture decomposition. By the way, I find that this decomposition, as I'm teaching it, is not taught anywhere. I mean, anywhere, not in the enterprise architecture methods. Correct me if I'm wrong, show me the stuff. and not outside of the IT area. Everything here, as far as I'm concerned, I learned the hard way for decades, and I finally wrote it down, the Theory of Decomposition. Maybe I'll write a book on that. But here's the little booklet on it. I have this 51-page book mentioned. So the basic idea is ancient, and I'm sure if Descartes said this, then Socrates and Aristotle did too. In other words, it's an ancient idea. And in fact, in this book, Principles of Software Engineering Management, there's a chapter called Deeper Perspectives on Evolutionary Delivery, which I can send anybody who emails me, tom@gilb.com. I can send them this chapter electronically. And what I do is look into all the other disciplines, not just software, but also software, which have understood the methods of Agile or EVO at earlier stages. I do have a digital copy of that, even though I don't have a really good digital copy of the whole book. But I'm happy to share that with people that I would like to go into detail, and I'd love to have your digital copy. Okay, there are some basic principles of decomposition, but basically if you just say to people decompose, they get the idea, but you have to interject decompose so that each sub-element can be implemented independently, and so that each sub-element will increase the sum value or values in the direction of your, as an increment of your long-term values. Those are the very, very basic ideas. If you have a cycle of development, maybe you have a plan to act cycle, maybe you'd like to think about adding to your cycle, like putting in a decomposition element in the cycle. So we've enhanced the basic Deming-Shewhart cycles by adding elements that are not explicitly there, but we think need to be explicitly there. Let's see, why do we decompose? In other words, what is the justification for learning the discipline, practicing it well, and doing it at all? And lots of good reasons, but the main reason is so we deliver value to our stakeholders. A lot of people talk about delivering value. But the first thing I do is I look, have they quantified the values anywhere? And the answer is time and time again, no. And then do they have any concept of decomposing so that they can deliver value? No. Okay. In other words, a lot of people give what we call lip service to the idea of value, but they don't do the things that are necessary that I'm teaching here to get the value delivered. One of them is quantification of value. Another is decomposition, so we can deliver values early. A third is the dynamic design to cost in the IBM clean room, so that you can adjust when you've got it wrong or partially wrong. And a whole lot of good reasons why we want to decompose. Okay, here is a simple example of a training course getting each team to decompose. They don't have any problem, but typically you have to coach or nudge them. Are you sure that each one of these can be delivered independently of any one of them and that it delivers value? If the answer is no, we talk about why and they get the idea, and 5 minutes later but you really have to teach it explicitly, because it's not just any form of decomposition. It's decomposition by independently deliverable value. Okay, a tool which is basically a spreadsheet for understanding the decompositions and how good they are on many values, and for rating them so that we can prioritize the most promising ones first, either by a tab table value or by bar charts, doesn't much matter. But we can automate decisions based on data for what should we do first, which small steps. These are small steps. Which small steps should we do first? Okay, you can do the same with the larger steps. I went through a concept here called backroom and front room. I referred to the competitive engineering book, Evo chapter, or use the index, the theory of backroom, front room, but it's sort of like kitchen and restaurant. And what it does, it solves the problem of when you cannot decompose a 10-week thing into 1 week. It's going to take 10 weeks to deliver, or there's some other reason it cannot be decomposed. But what you do is you wait until it can be delivered in a 1-week cycle, even though it took 10 weeks to get there. And the result is we can give an even stream, a value stream, a value delivery in the restaurant to the stakeholders eating at the restaurant. And the other thing here is that compared to conventional Agile and Scrum, what we're doing is we're adding value management and value feedback so that the work we do, it could theoretically be use cases and epics being programmed, but the work we do gets evaluated and gets measured. And if we get negative results, we go back and we fix things so that next time around it's better. Okay. So we're adding basically to conventional thinking, we're adding deeper stakeholder analysis, deeper value analysis, a clear idea of design or architecture, which is typically totally missing from Scrum and those things, an idea of decomposition, and ideas of measurement and learning. So we're adding quite a lot to conventional Agile. As far as I'm concerned, conventional Agile is not very good at delivering value. I said that very politely, didn't I? Read my free book download, Value Agile. So yeah, here's a reminder that the practice of this has been done and reported for a 10-year period. Is that long enough? Vaccine testing, very successfully by IBM in public, with an architecture playing center stage role, adjusting the architecture gradually, what I call dynamic design to cost. So it's well worth reading the original and saying, why in the heck didn't I learn that when I was at university if it was done before I even went to university? And the answer is our professors don't keep up with what's going on. Was I polite enough there? Okay. Finally, these ideas are old. I've been doing them since 1960. In Norway, I wrote about them 16 years later. And maybe it's about time when we're unhappy with the very high rate of failure of IT systems, such as Axon, such as Smittestopp, such as the Swedish teaching system. And when we're tired of that, we might learn to do Agile properly, which will manage the flow of successful value delivery early and consistently. We just don't get it yet. And all those people who are talking about Agile and other meetups probably don't understand this. You can ask them, okay? And they're welcome to argue with me. I'm arguing with them, so they're welcome to argue with me on the internet, in public, or by email. Okay, so yeah, here we have the multiplicity of values with the multiplicity of resources being managed in small increments, and that's the end of it. So we're at 5 o'clock Norwegian time. Just to remind you, next this coming Thursday at 4 o'clock, we're going to do dynamic architecture prioritization, which is, and if you want, it's there we go. That's my 5 o'clock reminder. By the way, if you want to go very deep, you can either read this chapter, or you can go to my value planning book, free chapter on prioritization in the Dropbox there, or read a short idea which says that managing priorities with fixed weights, as in balanced scorecard and quality function deployment, is a very bad idea. But you were probably taught those ideas at university, but so much for the university professors again. So that's the exciting next area. And of course, decomposition is a prerequisite for prioritization of these things you have decomposed. So with that, I'm going to stop talking and take questions. And let's see, is there, should I be looking at a chat, or somebody should do this orally?
I think people can just shout out if they
yeah, okay, turn on
have
your
a
microphone
question.
and talk. And I'll put the picture of everybody there. And as usual, Norwegians very shy, but we know that. So we're all the non-Norwegians like myself might like to ask questions. Tesfaye, thank you for your nice remarks on the LinkedIn today about this. And good luck at the Health Institute. Okay.
Thank you very much.
Questions, counter arguments, suggestions of better ideas or equally good ideas, all very welcome at this point.
Oh, we've got a tough crowd today, huh?
Tom, I have a question.
Yeah, from India, New Delhi, right?
Yes.
Welcome.
Tom, when you were talking about decomposition, one of the principle that you said that you could decompose by functionality.
Yes.
So also the decomposition should be independent.
Yes.
How would we evaluate that the decomposition that we have done would lead to something like completely satisfying the value of the stakeholder?
Okay. Now you threw in something at the end called completely satisfying the, and no adjective like functional, value of the stakeholders. So first, let me tell you that you need to understand my definitions. Now there's a glossary at the end of this book, and there are extended glossaries in, say, the competitive engineering book and elsewhere. So first, the word function. It's very simple. It is defined as what the system does. It's an action verb. And a lot of people use the word function on designs and all kinds of other strange things, you know, features. So we need to start with a clear idea of what is a function. It is not a value. Value is defined as how well the function functions. In other words, how good is its user friendliness? How good is its security? Entirely different type of requirement, okay? So when I talk about decomposing function, let's say we have two functions. One is read and the other is write. And we decide it would be very useful if we could read things on the system in the very first week. And we don't have to write yet. We just read what is there, read only. And so we do that. We said, oh, we can read and everybody can read. Now, what are we going to do week 2? We will write to the system. Okay, I mean, that's a very, I gave that very simple example of, and how do you do that? Well, you implement the read and see if anybody can read it. You test it. You implement on the second week the write function and see if you can write anything, and you test it. There's no problem there. Now, I think I'm going to stop there and say, did that sort of answer your question, Yagan?
Yes, Tom, but how would we measure that the functionality has been completed?
Okay, now, I thought the answer was obvious, but I'll try again. If you think you have implemented the functionality called read customer records, okay, it should be obvious that by trying to read customer records and not failing at all reading any, then you have proven by testing that you have succeeded. In other words, normal testing is my simple answer. Most testing is very function oriented today. Very little testing is on measuring the values of things like security and user friendliness, okay? So the answer is normal testing of functionality is the answer how you would know if it is working. Did that help you yet, Jagan?
Yes, yes.
Okay. The problem may have been in, you know, knowing that I have a special definition of function, but it's in all the books. And many people have what I call a sloppy definition. That's just any kind of stuff you program. It's just called function. And then they have a thing called non-functional requirements, and they're very vague about what that is too. This is an immature culture that says non-functional instead of value and quality requirements. Thank you, Jagan. If anybody else? Oh, come on. Don't
I can maybe give an example which leads up to a question. Many years ago, we developed a system for taking exams, and we divided the system up, what you called by stakeholders. I didn't know it was, but that's what we did. I didn't know it had a name, yeah, because the let's see, we did it. The one person developed the thing from the administrator point of view, another from the exam proctor, and another from the student.
Good. That is
Yeah.
stakeholder division.
Yeah, the stakeholder division, and it worked really well. This system's been in production 13 years now, so it's doing well. But we couldn't deliver. You couldn't actually take the exam until all three were delivered. You know,
Yeah.
Although it was like that, you couldn't actually get any value out of it until all three were delivered.
Yeah.
Final value.
Right.
You could do the administrator first, and they could start to configure the exams, but you couldn't actually do anything until the whole thing was there.
Right.
Often we have that the whole chain has to be in place.
Right. So one interpretation of that is you did not decompose so that value could be delivered. And that might mean that your stakeholder decomposition wasn't the right way to go. Maybe 3 stakeholders were necessary at one time, and then maybe you had to divide it up by functionality and get some functional value, or divide it up by a value such as security and get increased security. So the problem is you weren't conscious of different ways of subdividing it, and you accidentally subdivided to a stakeholder who themselves couldn't receive the final value. That's one possible interpretation.
Mm. Yeah, on the security there as well, we couldn't go live without the security being in place, because if something went wrong, we would be on the front page of the newspaper. That's
sure.
The thing is, it affects all the children in Norway, so it's it's a very
Again,
very interesting.
I hope you're not saying, but it sounds like you are, that it was security was black and white, all security or no security. Okay.
No.
Because I believe there are degrees of security, and most people do not have 100% of all imaginable security, far from it, as we're learning. So the rule here is that in the short term, in the long term, we'd like to reach our goal regarding security, enough security, right? So the Chinese and Russians can't get into parliament, but and the health system, which they have done in Norway in both cases. But you have whatever bad security you have, even in a manual system. Maybe you were replacing a manual system. Any increment whatsoever next week is better than 0 increment next week. And if you have a series of 10 weeks of increment and you reach your goal after 10 weeks, that's fantastic compared to spending 8 years studying Axon at PwC and getting nothing. Okay, so in other words, getting some improvement in the short term, which is an agile way of thinking, is a much smarter idea than getting no improvement for 8 years and then being faced with another 8-year project and 22 billion before you can get anything. That's just stupid Big Bang waterfall thinking. We've got to stop it. I didn't say you did a stupid project at all. Didn't mean to.
Mm-hmm.
You get the general idea that some short-term improvement better than you have is not going to hurt anybody. If you did an improvement, it would be worse next week if you didn't do the improvement than it was last week. I mean, it would be equally bad. If you improve it, it's better. Better is better than nothing. No improvement.
No, but my point was that in some things you need the whole value chain to be able to deliver something.
So you might have the what I call the backroom problem there. You might have it. Now, I believe you don't really, have it, but I believe that you think you do. So what I normally encounter with this decomposition is everybody tells me, Tom, this cannot be decomposed, and we'll tell you why. And they're actually domain experts better than I am in their own area. And you know what? For about 4 or 5 decades, they have all been proven wrong the same day by me suggesting a simple way of doing it, where they say, when you think about it that way, it can be decomposed.
Yeah.
And that's what I'm teaching.
Yeah. I'm
quite accustomed to people saying it can't be done, but you give me your real system. We can have a dialogue about it anytime you like. And I'll tell you what you could have done. And you'll say, oh, that was so simple. Why didn't we think of that?
But I'm not saying it cannot be decomposed. What I'm saying is that in some cases you need a full value chain to get any value out of it. I can give you two more examples.
Okay.
For an online bookstore, you have to be able to browse books, order books, take the payments, and deliver the books. Yeah. So if one of those is missing, you can't order and get the book.
Yeah. Okay. Now you're missing a point I made very subtly. The point is, you're thinking in terms that IT people do all the time. They're going to build a complete new system, and when it's done, they'll deliver the new Oxon system or whatever it is. Okay. Now you notice I said that we start delivering the value next week to the old awful system, no matter how bad it is, and no matter if it's not even an IT system. Okay. That means that I have all the functionality I need in place. So you may be using the new automated system to order the books and the old manual system to deliver them in the meantime. Okay. But you have, if you use the old system, and there's always an old system, you already have everything you need. You can focus your attention on improving the values and qualities that are not good enough. This idea of rebuilding the system from scratch is a stupid Big Bang waterfall idea, and it is not agile, and it is not necessary, ever. I've been doing this for 50 years without exception, but I keep on, I'm not talking about building a new IT system. I'm talking about quickly improving systems, sometimes with IT, and sometimes, without doing any IT programming or anything whatsoever. I might increase the security by having better contracts with new employees, to take a simple example. So we've got to get out of this narrow-minded, we are building IT systems. Okay. The enterprise systems we're talking about are large, complex, old systems that are need enhancements, usually to the values and costs. So this is a method for early getting value to cost delivery in place. And we use the existence of the old system, whatever it is. And you've got to get your mind around that. We're going to apply, use, and keep the old system. After 100 small increments, weekly increments in 2 years, the old system might be gone. It might be replaced by all kinds of hardware and software and databases and internets and everything. But in the meantime, if you want quick improvements, you have to make use of the old system, whatever it is. And by the way, I built a system at University of Oslo Press in 1968, Universitetsforlaget, that did exactly this, step by step, using the old system. And I can give that to you in detail and have publications on it. Got it?
Yeah.
Ask me for the Universitetsforlaget example.
Yeah. Okay. Yeah. So that means you build on the new system. You gradually replace it, or you gradually improve it.
Exactly.
Yeah.
This is the new idea that most IT people don't grasp. They just want to program a new system because I'm a programmer. They don't care about actually delivering value to the publisher. Let me tell you a short story about Universitetsforlaget system. Mr. Borgerli, who was the director of University of Oslo Press at the time, and I was the project manager of the new IT system for ordering books at Universitätsverlage. And we had the first meeting with Mr. Borgli, and he said, Tom, the IT people who've previously tried to make such systems for us are so awful that they've made bad systems that hurt and destroy our business. I hate IT. And although I'm forced by the corporate bosses here to play games with your IT system, I'm going to tell you right away, I'm going to sabotage it so your IT system doesn't come in and destroy my business. Okay. Now, I did it step by step, and I can't take time to show all the steps here, but actually the first step was automatically going from the name, author and name of the book to the book number automatically. They had a manual system for doing it. We didn't change anything else. We just did that. That system was so spectacular that every time visiting publishers from anywhere around the world came, Mr. Borgli, who is now our supporter, not our enemy, said, demonstrate this fantastic publishing system that nobody in the publishing world has except me in Norway. Okay, in other words, by doing it step by step, and the first step was making friends with the enemy who was going to kill the system by doing something so sexy that he loved it and he didn't feel threatened. Okay, that's a long story, but a factual story from 68, 69, which is published, and I'm happy to share that with anybody. But we did it step by step. First step being conversion of incoming manual slips with name and title of book to international standard book number, which was a manual process. We automated it. That was step one, value step one. We were doing, by the way, in the same place at Studentsamskipnaden, which is part of the university here, we had two parallel projects for payroll and accounting. They also were had to be delivered in 1 year. They failed, one of them 5 years in a row, because it tried to do Big Bang, until they finally got the idea of doing it agile and evolutionarily. And I can tell the detailed story and name people you might even know who are still floating around Norway. They were educated at Bedriftsøkonomisk Institute, these guys who had no idea of how to manage IT systems. But they failed and failed. Ours succeeded. Okay. You having fun yet, Shiraz? Are you still there?
Oh yeah, I'm still there.
Okay. Have a long chat with you anytime you like about publishing systems or any other system. Next question. We have another 15 minutes or so.
Yeah.
I do miss one good reason, to decomposition. That's in enhancing communication, because you can decompose at the higher level to the leaders, and you go deeper to the solution architects and something like that.
Good. So I completely agree with you. And by the way, I have a booklet called Clear Communication. And if I remember, or you remind me, I'm going to send you a free copy of it, Tesfaye.
What's the title?
Clear Communication. I wrote a note. You'll probably get it right afterwards here.
Yeah,
but
thanks.
Since you're obviously interested in clear communication, I wrote a whole book on how these methods help clearer communication between people. But you're right, decomposition helps communicate ideas because you have smaller increments that are more visible, as I hinted, right? You're absolutely right in your observation. It's part of a set of tactics that allow us to communicate more clearly about complex technology. Well spotted. No, Norwegians asking questions. What are we going to do about it?
Let's see. So maybe I can try to. Have you heard of the team topologies?
Team
topologies. It's a company that's came out with a way of organizing teams.
Okay, I think it sounds so generic that No, I don't know about it, but
Yeah,
send me something
no,
and I'll
yeah,
evaluate
but
it.
one of the ideas they have is that you should divide up the teams based on cognitive load. And
Yeah.
that's also a way to decompose the system, that each
Yeah.
part of the system shouldn't be so large that one person can't understand or the team cannot understand it.
Right. Well, I agree with that. And I would say that everything I've said today is in support of that sympathy or idea.
Mm,
So, but I would appreciate if you'd send me a link and I can look
yeah.
up, I'll make a note, but teams, but it's so generic that I thought you meant like team instead of Zoom.
No, that seems foolish. That's we've had
I'll
some.
check it out. I'll check it out. But it sounds like in sympathy with exactly what I'm saying.
Yeah, because what you were saying based on the knowledge that people should be able to understand what they're working on. There shouldn't be too much.
Well, this is Rene Descartes' principle of making complex systems more intelligible.
Yeah.
That old.
Tom, in continuation with the previous question,
Yes.
There's a Conway's law.
Yes.
So shouldn't the architecture also influence the organizational structure?
Yes. Now, you'll notice the last lecture we have planned, chapter 9, is, and you can read it anytime you like, I speak about the organization and organizational positions. For example, this simple idea that the chief architect has the role in between each sprint of getting the feedback and changing the architecture. That's a new idea of an architectural responsibility. Okay. So what I've done is I've taken a look at all this technology I'm talking about and said, what does it mean for who is responsible for doing what and what they must learn? Obviously, an architect has to learn to decompose by learn all the tricks of the trade. And it's a new idea of that responsibility of the architect is to decompose so that we get early steps. Let's call it the agile architect has to do that. The Big Bang architect doesn't have to do it. Okay. So I'm interested in the organization and I write about it in chapter, is it 9, I think, that we've planned to do a few weeks hence. So that's my simple answer. Do you want to ask any more about the organization or something specifically?
No.
Okay, we can talk about it anytime you like. But I believe that the major responsibility for the architect is to know what values need to be delivered and to find the architecture to deliver the values. That is a new idea that is not well covered in any of the enterprise architecture methods I've seen. Some of them don't talk about it at all. Some of them talk about it and don't do anything, okay? I would appreciate it if anybody would show me any known or little known architecture, IT architecture method, which is specific about quantifying values and finding architecture and estimating how good the architecture is for the values. I don't find that at all. And I think it's the primary idea of what an architect should do. Okay, so I'm literally saying we are missing the primary idea behind an architect in much of what we do in so-called, TOGAF, Zachman, any other kind of enterprise architecture. I remind you, I've taken this up directly with people like Zachman, who do not disagree. They just want to keep on doing what they've always been doing. It's the answer.
Yeah, let's see. Just two things. One is a comment on Jaran's thing with Conway's law. There's one of the things with that is that the consequences of that is that the human resources department end up designing the system because they design the organizational structure of the company, and that affects how the systems are built.
Oh dear.
So that's the one. It's not a problem with Conway's law, but it's a problem with the consequences of Conway's law. But the way you can get around, there's a thing called the reverse Conway maneuver, where you design the system first, and then you look at your organization and change your organization so it matches the design of your system. So that's very good.
You know, in discussing organization, what I found is that I'm less interested in who has a position and the organization chart. What I think is most important is that certain things are done, like quantifying the values of the stakeholders by somebody, and I don't care who does it as long as it's done. And if it's not done, if we have not quantified our value objectives, then the whole organization is going to fail to deliver value, okay? In other words, my focus is on what things must be done by somebody, and smaller organizations will always be different from very large organizations in who you assign the task and how specialized you are. But to not quantify the value objectives is the beginning of not being able to architect the value and deliver the value. Okay, so again, I'm less concerned with organization in the conventional sense, and I'm more interested in the certain things get done at all. Do we decompose properly? Do we measure, get feedback for how much value we got on a step? These kinds of things. They're the most important. For example, the measurement, is it done by the testers or by the architect or somebody? I don't care. It's very important that we get the feedback and measure. It's fundamental, okay? So you can call these positions anything you want and pay them anything you want and give them power, but you need to do certain minimal things that I'm spelling out for you in this book, or you will not get value delivery, and therefore the systems will fail, and which they are doing on a large scale right now. Google IT project failure and weep.
Yeah, see, and yeah, so it's like the song really. But yeah, and another thing on measuring, on systems that measure value, you have the IASA, the International Association of Software Architects. One of their pillars is business strategy,
yes,
and that includes cost-benefit analysis. So that they teach cost-benefit analysis as part of their course.
But do they, if you go into benefit, will you find values such as security and its benefit? And I'm guessing the answer is no. They're doing more of a conventional economist thinking. They're not thinking of the technical attributes of the systems, which are the primary attributes for our systems, such as security, user-friendliness, maintainability, and things like that. So I'll bet you, I challenge you, show me IASA, which quantifies qualities which are critical to the system. I have been poking around and I haven't found it.
Okay, I'll look it up for the next course.
Or in between, yeah.
But on the security, it's become much easier to quantify it with GDPR, because then you get a fine. Yeah, and then the business people, they can see, okay, this is what it costs to do it, and this is the fine that we have to pay if we don't do it.
Yeah.
So then the quantification has become much easier.
I could have an argument with you on that. Like GDPR is about privacy, not security, for starters, and it's not.
Yeah.
It's not a good quantification tool. But we can have that argument.
Yeah. Okay. Yeah. Now,
we got one more minute. Last chance.
Sometimes I don't know what they call it in English, but you can't measure omdöme. What is
your reputation.
Reputation, right? Yeah.
Now, Tesfaye, I want you to take reputation or omdöme and the word metrics and Google it, and you will find many, like thousands of answers to how to measure reputation. By the way, people in marketing do that all the time, and they've been doing it for about 100 years or more. So it's just objectively wrong to say you kan ikke måle omdømme. It's just wrong. Look it up, Google it, and see how people have done it. This is This is what people, this is the problem. People think that critical values like that cannot be measured. And I'm sorry, thousands of people have already done it for everything you can imagine. Google security and metrics, Google usability and metrics, Google reputation and metrics, and get a few thousand people who've done it and will share with you how they have done it. No, okay, if you can't, we have never found that you cannot already, if you are concerned with it, you will find other people have been concerned about it, done it, and published it on the web every time. It's old. It's not even new. Anyway, we have reached the end of our Q&A. And gee, I wish the Norwegians would get a little bit more active, but I'm sure they're all learning and thinking, but not speaking. So on Thursday, we do prioritization, very exciting topic and very different from conventional thinking with fixed weights, as in balanced scorecard and quality function deployment and other methods. Okay, we're gonna have dynamic prioritization for architects. We can turn off the recording and quit.
Okay. Okay, thanks a lot.
Thanks, everybody.
Yeah, goodbye.
Bye-bye.
Okay, bye-bye.